Okay, well, good afternoon. It is a pleasure to be with you all today. My name is Mason Egger, and I am a developer advocate for DigitalOcean. Today, I will be going over building a minimal production-ready infrastructure on DigitalOcean. So, just to talk about what we're going to be doing, we're going to quick outline of all of our stuff. We're going to have a high-level overview of all of the things that we're going to be building today. So this is mostly going to be a live demo, a live presentation using Terraform to build out all of this stuff. There's going to be very few PowerPoint slides. So we're going to go over the architecture of this thing, of what we're going to be building. We're going to go over the DigitalOcean products to be used. Mostly that is going to be all of them. Then we are going to do some live coding with Terraform. We're going to create some Terraform files to create this infrastructure. If you would like to follow along or deploy your own code with me or take this and do it later, the source code for this is at do.co/tf-sample-arcs. This is a project that I've been working on where I'm making different Terraform architectures or different architectures on DigitalOcean using Terraform. And all of this has already been commented and documented. And even during this presentation, I'm going to be referring a lot back over to these on my side screen. So we're basically going to be going through and working through this, this demo together. So that being said, this is the architecture of what we are going to be building today. So this is a minimal, what I consider personally as a minimal architecture for a what's considered a LEP-based stack. This is basically Linux. We're going to be using Nginx as our web server. Postgres will be the database that we will stand up today in using Terraform, but MySQL or any other database would have been just as fine. And then I'm also going to be not really focusing on the web technology, so that's why there's a star there. Usually there's a fourth acronym there, P. It's usually P for PHP, Python, maybe R for Rails, and some other stuff. We're not going to be focusing on that at all today. The web servers that we will be deploying a simple, basic, static HTML page, and nothing really much more, because then if I did that, this entire presentation would be twice as long. So basically, this will be a great architecture for you to deploy your own, whatever web technology, web framework, whatever tickles your fancy. That's what you can use. So a redundant web cluster that can access the database is what we will be building today. So all these web servers will have access to the database, and at the same time, we will also have traffic ingress through our load balancer using SSL termination. So this essentially means that we will be accepting stuff on a common DNS port coming in to a certain website like www.mason.com or something like that, and that will be coming in across HTTPS. But with SSL termination, we're actually going to terminate and do all the decrypting at the load balancer level, and then forward that traffic across HTTP inside of our cluster. We will have SSH access through the Bastion server, and then all of this, as you can see in this picture that surrounds it all, will be inside DigitalOcean's latest product that we have released, which is the virtual private cloud. So all of this stuff will be isolated and secure from the open web, and we're going to be building all of that today. So the DigitalOcean products to be used, we are going to be using virtual private clouds to protect and isolate our traffic and our data to make sure that nobody can sniff our traffic. That way we can get away with doing SSL termination and not being worried about it being HTTP traffic inside of our VPC, because it is isolated from the outside world. We are going to be using multiple droplets. There will be 3 droplets used for the web servers, just to kind of show you a sense of redundancy. We can easily tweak this number, as you will see. There will also be a Bastion server that we will be deploying that will give us SSH access into our system, because our web droplets are not going to have any public facing IP addresses, or they are, but we're going to be blocking them with firewalls. We could turn them off, but that's a little bit trickier. It's easier just to block all that access with firewalls. Then we're going to be using DNS to create DNS records, so that way you can actually access all of your things through, like we'll have a DNS record for our Bastion server and then a DNS record for the website that we are creating. We will be using firewalls to enforce security and traffic flows, both inbound into the VPC and internally to who gets access to the database. We will be using load balancers to route the traffic to our different websites, and then, or to our different droplets, and then we will be using managed databases. And in reality, all we're really going to kind of focus on here is just that it is there and that it is accessible via the web droplets when we SSH into them, that we'll actually be able to use like PSQL and be able to get into it. We're not going to be actually hooking up the website to the database. Again, this would be focused more on the top level stack stuff around the web framework and technologies. Most things use ORMs, so you would be seeing that. So we're really not going to do too much with it today, but we are going to configure and set up and have our database ready to go. So that being said, let's go ahead and get to work. Needed some water. So we're going to exit out of here and we're going to go to VS Code. So I'm going to create a directory with a couple of files in it. I've already created a main.terraform file, but I'm going to create a couple of other files really quick that also, basically, you can consider these almost like the 4 files that you would be using, that I personally start my Terraform files off with. There's the main file, which is main.tf. There's data.tf, which will be a file where we will put all of our data sources. I want to read all of my data sources in, and I don't really kind of want to intermingle them, and I want them to be accessible easily across the project, and I want to be able to just know everything's there. So we're going to create a data.tf. I'm going to create a variables, spelling, not my strongest suit, .tf file, and this is where we will allow ourselves to parameterize our Terraform files so we have more flexibility with how we can use this. And then the last thing I'm going to create really quick is called outputs.tf. Now, that being said, there's going to be a lot more files in here, but we're going to start off with the bare minimum. So the first thing we're going to do is, because we're using DigitalOcean, we're going to create the provider block inside of here. So we're basically going to say provider DigitalOcean, and we're basically going to say the token is going to be var.do token. Now, we haven't actually set up a DO token yet in our variables. So now that we've actually used it, let's go over to variables and go ahead and create that. So just real quick, what this provider does is, this provider is what allows us to know, hey, we're using DigitalOcean. So we're going to go over to variables, and we're just going to say variable DO token, and we're going to say empty parentheses. This will be pulled in via environment variables. So if I go back over here, the first thing I need to do is I need to do a one second. Yeah, I need to tilde.terraform plugins. Okay, so I'm actually a maintainer of the Terraform, DigitalOcean Terraform provider, and if I had loaded that, it would have loaded one that I was working on, and I don't want that. So real quick, had to do that, get rid of the old one. So as you can see, it actually downloaded now. So we do a Terraform init at the very beginning to say, hey, I have my providers in place. Let me use DigitalOcean's Terraform provider. And it downloaded it for me. And we're good. I know this came from the website, because if it hadn't, it wouldn't have shown this. It would have come from my local thing. I may do a webinar on how to build your own Terraform modules and your own plugins. If that's something that you're interested in, please leave comments in the comment section below, because I'm always looking for new ideas for content to create and more tech talks to do. So now that we have that set up, we're ready to go. The Terraform on our side is ready to go. And let's just go ahead and just run a quick Terraform plan and make sure it works. So Terraform plan, and everything's up to date. Now, what you would typically do is you would export, or how I do this for this variable, because you see, you didn't see me put it in at the command line, and it's not stored in that file, which are 2 options that you could do. If you export tf var underscore, and then the name of your variable, and then some stuff, which I'm not going to do because it'll break my stuff, this will be picked up by Terraform and used as your token. So if you don't see me using the token or doing it anywhere, it's because it's currently exported into my environment variables. So next step, we have our provider up and running, and now let's just refer back. I'm actually going to do this a lot. Let's refer back to our architecture diagram and continue on. So there's 2 ways of thinking about how you kind of want to build architectures and stuff like this. Personally, when it comes to this type where there's a lot of networky bits, especially where there's like a VPC. I like to build from the inside out, but when there's a VPC, I build the VPC first. I want everything that I'm going to be doing to always be inside of that secure center. So what we're going to do now is we're going to create another file called network.tf. This network.tf file is going to be where we create our VPC. It's also where we could create a lot of other networky type bits that are not directly tied to resources. And you'll see later, like when I create DNS records for specific droplets, I create that DNS record inside of the droplets Terraform file, not inside of the network Terraform file, even though it technically is, because it's heavily tied to it. DigitalOcean, really and truly, your network file would only be the VPC, because I also create the load balancers and stuff in the same area. If you're doing something like this on AWS, where you have to create a lot of gateways and a lot of other more generalized things, it might be wise to put them in here. But for DigitalOcean, I personally have just found that the only thing that I've needed in the network file, we're going to call this webinar VPC. The only thing I've needed in the file is just the VPC. So the region, and instead of hard coding the region, we're going to go ahead and just use a variable file because I don't know what region I want to deploy into. So we're just going to go ahead and create it. And every time, that's basically how we're going to go through this, is every time I have something that I know I kind of need, but I don't want to hard code it, we're going to put the variable in the Terraform file, and then we're going to go to our variables file and add it. So name is required, region is required, and then now DigitalOcean will provide you an IP range all of your own if you don't already have one, or if you don't specify one. But if you choose to specify one, it will take it. So I'm just going to do private IP block of 192.168.44/24. So I'm going to have roughly 255 IP addresses. Give or take, because DO reserves a couple of IP addresses for our networky bits. This means that this is actually the smallest VPC that I can make. Personally, I would like to make one a little bit smaller, but since this is what we have, this is what we have. So now that we're going to make a /24, let's go ahead and flip over, and let's go ahead and create our VPC. Oh, nope, not going to work. We did not create our new variable. That would have caused a problem. So what we're going to create now, variables, is we're going to create our region variable region. And then what I'm going to do here is I'm going to set what's not like a same default. So the first thing actually we're going to do is we're going to set the type. It is a string type. And then the default region that I want to put this in, or the default value, we're going to say is NYC3. Actually, let's say NYC. No, let's do SFO3. That's a new data center we have now. I hope I'm right on that. I'm pretty sure I am. So we're going to create this in San Francisco 3. So if I come over here, I'm in Austin, Texas. So New York to San Francisco, it's relatively the same distance. If I do a Terraform plan, you will see that it's going to go ahead and create a VPC for me in SFO3. So let's go ahead and just do a Terraform apply. I'm going to say yes, and I have a VPC. I'm going to double check this on my side. Yes, so if you see my screen, you can see that the webinar VPC is showing up here in San Francisco 3. So my Terraform did properly work. So good. If we go back to our diagram, we now have our VPC. Now we can start putting stuff inside of our VPC. The next thing I'm going to focus on are the droplets. This is really and truly the biggest part of the entire process. And this is going to be creating the web server droplets. So the way that I usually like to make my Terraform files is give them names that are meaningful to me. I could come over here and create a droplets.tf, but I'm going to be using droplets for multiple things, for the web server, for the Bastion server. It could be a whole lot. So what I'm going to do is I'm actually going to call this web servers.tf. That way I know these are all of the resources that are specific to the web servers themselves. This will also include the DNS records and the firewalls. This will not just be limited to droplets. So I like group your infrastructure and your architecture based on what the functionality of it, not the technologies that build it, and Terraform will work a lot better for you. Yeah, at least that has been my experience. So we're going to go ahead and create our droplets. And these are just going to be called web because they're web servers. We're going to go ahead and set a count, and then this is where we're going to start just putting a whole bunch of variables, and we'll come back to them. So we're going to say var droplet count. This is how many of the servers that I want. I may want to change how many of the servers I have before I run it, or I want to stand this up in multiple places, so I want to make that a variable. Same thing with image. I know that I'm going to want to choose Ubuntu 18.04 today, but maybe I want to deploy it somewhere else with Debian 8 or something, and I want to be able to change that on the fly. You're going to find that I use a lot of variables in a lot of places. The more variables you use, the more reusable your Terraform. So we're going to give each of these servers a name, so that way when I view them in DigitalOcean's cloud dashboard, I will see them different. I will make sure that it's not just going to say web server, web server, web server. We're actually going to do a little bit of variable interpolation. If you are accustomed to older versions of Terraform, you will maybe wondering why my variables don't have the $sign curly brackets. It's because Terraform 12 changed that. But if you're still doing variable interpolation, you still have to kind of do that, which is not Tegan region, which is needed because we're combining these with strings. So we're going to go ahead and do count.index +1 because I like seeing 1, 2, 3, not 0, 1, 2, because I can look for the largest one, at least when it comes to my naming schemas. Region, we're going to set it to var.region, which we've already set up, so we're good. The size of our droplets, we're going to set it up to var.droplet size. And we're going to be creating all of these variables in a minute. But again, I know that I want to be able to change the size, maybe based on a variable file or something, so I'm going to do it like this. SSH keys, man, we are just jumping into it. We are going to leave this blank for now. This is going to be like essentially blank because we have to come back and discuss that. The VPC UUID, and this is where we can start accessing other things. Whenever we created our VPC in the network file, it creates a set of attributes that can now be imported by other files. So we're basically going to say DigitalOcean _VPC .web, because that's what we named it up here, DigitalOcean VPC .web. This is the variable name of the resource, and then we're going to say ID. So now all of these servers will be created inside of our VPC, which is awesome. I love that feature. We're going to go ahead and set up some tags. This is mostly for our database stuff because we can set who can access the database based on how the droplet is tagged. So if I give it a specific tag and then I also make it where the firewall accepts rules in from the database for that tag, we can do that. var.name, and then we're just going to say web server. And then the last thing we're going to do is I'm actually going to copy and paste this through because I hate typing this by hand. This comes directly from my thing. We're going to set up a little bit of user data, which essentially is using Cloud Init to create stuff for us. So we're going to go ahead and write a cloud config file, and we're going to say that we want Nginx to be installed, PostgreSQL contrib. You probably don't need both of these files just to access it, but for now we're just going to use that. And then we're going to run a command that essentially will echo the name of the server, the full name of the server, so the web-region- the ID number, to our index.html. So when we cycle through these in our load balancer, we'll be able to see them change and we'll know that our load balancer is working. And then last step that I always tend to add, because it just makes your Terraform a little bit safer, is a lifecycle create before destroy. Yes, language server, I know you're upset. I don't care, go away. And this basically means that when you defaultly run Terraform, it will spin up all of your infrastructure and and then tear down the old ones. That's not the default. That's what we just did. If you don't, it tears down your old servers and then spins up the new ones. Well, if there's a problem in spinning up the new ones, your old servers are already on the ground and you have an outage. And so by doing this, we switch that. We basically say, do not tear down any infrastructure until you are positive that this infrastructure came up okay, which will save you from outages. Okay, so we just did a lot in a very short amount of time, so I'm going to just really quickly go over it. We created a DigitalOcean web resource. Our count variable is how many droplets we want to create. 1, 3, 6,000, totally up to you. The image is what operating system. So we're going to say we're going to use Ubuntu, probably 2004 for this. The name is just the human-friendly name that we're going to see in our cloud dashboard. It's going to be set to web-sfo3 because that's where we set our default, or so web-name. That doesn't look right at all. var.name. Oh, I'm sorry, var.name. So there's going to be a name that we're going to give everything. Region, and then the count index. We're going to go ahead and do region, which will say which region to put it into. We've already set that variable, so this will just put everything in the right one. The size, so like 1 CPU, 2 CPUs, how much RAM, all of that. SSH keys we're going to come back to. The VPC UID, so which VPC we want to put everything in. So that's what we're going to be doing with this one. It's going to be the one that we just created in our network.tf file. The name and then the web server, which again, we're going to do in a second. This is just a friendly name that we're going to give all of our stuff. Some cloud init data to install Nginx, Postgres, and PostgreSQL contrib, and then a command to write a default page to our index.html, and a little bit of housekeeping life cycles. So that was a lot. We need to go back now and add our variables. So the first thing we need to do is the droplet count. So let's go ahead and say variable droplet count. We're going to say that's a type equals number. And then the default we're going to set is going to be set to 1. It's good if we do it like this, just because saving money is nice. So we're just going to do it for 1 on this one, and we're going to just over. The next one we need is variable name, which is essentially going to be type equals string, and then the default for this is going to be webinar. Yeah, it's just going to be webinar. So this will be the name. Everything will just have this nice prepended name. The will be webinar, droplet name, webinar, firewall name, all of that stuff. It's going to be a lot easier. Whew. Okay. The next one we need. What do we need next? We need image. So we're going to say variable image type equals string, default equals, we're going to use Ubuntu -20-04-x64. You can get these. There's a website that you can go to that gets all these slugs, and I'll make sure that it's posted in the email, and that it gets back to you. Droplet size. Variable droplet size is, oh, I didn't put it in quotes. Droplet size type equals string, and we're going to go ahead and say that we're just going to use the standard droplet S-1 vCPU -1 GB. Not going to use anything special for these. This is not for this demo. But again, all these are interchangeable in a variables file. So we have that one. We have droplet size. We'll do SSH keys in a second. We have name. We already had region. We have droplet size, image, and droplet count. Great. So that's going to come up and be angry with me. Variables are going to be okay. The next thing we need to do now is address the SSH keys. So we're actually, let's make sure I did this right. Yes, okay, actually let's do one other thing. Let's add variable SSH key. And then we're going to say type equals string, and we're not going to set a default value for this. This means it will be a required variable of when you run it. So now we go to our data source. So we're actually going to use our data sources real quick, and this will be the only thing we use them for. This and one other thing. So a data source is essentially a read-only version of a Terraform resource where you can access data from your account or from your basically from the provider and bring it back in. So what we're going to do is we're going to say data DigitalOcean SSH key, and then we're going to say main. This is our main SSH key, and we're just going to say name equals var.ssh key. What this is going to do is we're going to give it the name of our SSH key. It's going to go to our DigitalOcean account. It's going to read that key and bring it back to us. So I don't have to store my private key, my public key like thing inside of here, which is actually going to be really nice. So now we go back over here to this SSH keys just to add it in. And then what we can do now is we will say data.digitalocean SSH key.main, that's the name we gave it, .id. And it will pull in our SSH key and then put our SSH key on there. So, whew, that was a lot. Let's do a Terraform plan. SSH key, ooh, what is mine? This is actually a good opportunity for me to make a quick change. Where are my SSH keys? I have to remember. There they are. Okay. Mine will be called home desktop WSL. Ah, none found. But that's what it's called. Let me go back real quick. Maybe I mistyped. Well, but before we do that, I don't want to keep typing this all the time. So let's go ahead and create one more file that we are going to kind of want to use for this. And then we'll figure out what's going on with that. We're going to say, we're call this sfo3.tfvars. We're going to go ahead and create a variable file that basically tells us what region we want to put everything in. So this is sfo3. Again, this is the default. It's not going to hurt it by doing it multiple times. Droplet count equals 3, SSH key equals, it should be home desk. I'm just going to copy and paste it out of here. Should be this right here. Home desktop WSL, and then that should be good. So now, whenever I come back to my terminal and I do Terraform plan dash var file, we don't want to use the out. We're going to say S. Did I not save it yet? sfo.tfvars, sfo3.tfvars. There we go. Okay, so that found it. Maybe I just mistyped it last time. So it has found everything that we need. It's going to basically say it's going to create these droplets. It's going to create 3 droplets: a DigitalOcean web droplet 0, 1, 2. And you know what? Let's go ahead and apply this real quick. sfo3.tfvars. You can also save this to an out file and it will work. But for now, we're just going to do it like this because I just don't know like it. How much time do we have left? Ooh, oh my. I have no idea how long this was possibly going to take, but I mean, we're making good progress, and really once we get to the droplets, it's not that much more. Also, sometimes waiting on Terraform can be kind of painful. It takes a little bit of time. If you end up doing this professionally and such, you will definitely see you will definitely spend a lot of time waiting on Terraform. That definitely happens. Okay, I'm just, yeah, okay, and we're good. So, so we're good, our droplets are up. So now if I go to my account and I go to prototypes, I will see my 3 droplets up. If I go to one of them, I should be able to see, ooh, that no worky. Interesting. Did I make a boo-boo? It wasn't actually really supposed to work at this point anyway, so I probably, Either way, we're just going to keep going on through that, and I will figure out why that's not working once I actually get to the part. I'm doing this, normally I do this all at once, and right now I'm kind of not. Oh no, did I? There it is. I was like, where did my thing go? So let's go ahead and continue. The droplets are up and ready to go. I think I will actually probably end up destroying them and recreating them once I have everything up and running the way I want it to. But the next thing we're going to do, interesting. We'll deal with that later. Next thing we're going to do real quick is let's go back to our architecture diagram. let's go ahead and do the load balancer and the DNS records. Let's finish the web servers file. So now that I have that, I'm going to go ahead and create some certificates. But the last thing I do want to put in here is I need a few more variables before I get going with that. So I'm going to go ahead and put the last ones in for the variables that I need. We're going to need variable subdomain, and this is going to be type string, and we're going to require someone to put that in, and then variable domain name, put that in quotes, and that's also going to be of type string. So we're going to go ahead and create these variable files, which will allow us to basically set up our DNS records a little bit easier, is what we're going with here. And then I'm going to just go in my sfo.tfvars, and I'm going to go ahead and finish this last one off real quick. So the subdomain is going to be equal to webinar, and the domain name is going to be equal to egger.codes, because that's the domain name that I already have installed here. So that's going to be pretty much all we have for the variables. The point of this variables file is if I wanted an NYC3 variable file, I could change it, and then I just change this region file to NYC3, and then I can spin it up in NYC3 easy peasy all by myself. So we're going to go ahead and close that file because we're done with it. And then we're going to go back to web servers, and we're going to go ahead and add a DigitalOcean certificate. So we're going to create, actually, we're going to add a load balancer first. DigitalOcean load balancer. We're going to call it web as well. We're going to go ahead and give it a friendly name. And you're going to find that a lot of the things that you have to put inside of your Terraform are like a lot of the attributes are the same. Like it's going to need a name. You're going to have a region. That's very typical to always have region, because you got to tell stuff where to actually place it. We're going to say which droplet IDs do we want to put this behind, and we're going to say DigitalOcean droplet.web.star.id. Now you have to do that .star when you have more than one. So since we are going to be creating more than one, it has to have that, because basically it's going to kind of unravel the loop and then associate it with it. We have to associate this with the VPC. So VPC UID is equal to DigitalOcean _VPC.web.id. We're going to say redirect HTTP to HTTPS to HTTPS. We're going to say true. My goodness, because we do want to redirect all of this. Then we're going to go ahead and set up we're going to always do your lifecycle create before destroy. Then what we're going to do is we're going to set up some forwarding rules. And basically we're going to say entry port is equal to 443. And then we're going to entry protocol is equal HTTPS. And then our target port is 80. That's what and then our target, my goodness gracious, target, good grief, protocol is equal to HTTP. And then this is where we're going to have one that we don't have yet. Certificate ID equals DigitalOcean certificate.web.id, which we haven't created yet. And then since we haven't created that yet, let's go up and do this up here. So DigitalOcean will create HTTPS certificates for you, automatically renew them, automatically deal with all of that. As someone who remembers when certbot wasn't around and then had to start using certbot, and even then certbot still sometimes does weird things to me, it is so nice to have DO able to manage our certificates for us. So let's go ahead and just do another resource. DigitalOcean _certificate, and then we're going to say web. It's nice to just give it easy names. And then the typical boilerplate, the name is going to be var.name-certificate, just to make our life a little bit easier. The type is going to be let's encrypt. You can use the DigitalOcean Terraform provider to provide your own certificate if you want to. but I'm mostly just going to use this. Then we're going to say var.subdomain. This was a weird hack that I had to do, because if I don't, it will I created a circular dependency error and got stuck on something for a little while. Lifecycle equal create before destroy. So the domains basically tells it where to go. Now, as you can see, I use a data source right here, DigitalOcean web.name. I haven't done that data source yet. This is the last data source that this particular architecture uses. And again, this is data sources, if you are just tuning in, are ways of being able to use read-only stuff from your DigitalOcean account. So since I have Egger.codes being managed by DigitalOcean, and I can create those DNS records on it. So if we come back to prototypes, come on. If we come back over here, you can see Egger.codes is right here. So since I have it registered in DO and I can create DNS records with it, I can read that domain name out of here and just make sure that, one, by doing this, instead of just using the domain name, it makes sure that DigitalOcean actually has the ability to manage that domain, which you don't have to do. You can totally do your own stuff, but since I already have everything inside of here, this verifies that whenever I put a domain name in, that yes, DO actually can use it. So we're done with the data. We've created the subdomain, we've created our certificate for our load balancer, and we've forwarded it to the right place. I think we're almost done with the web servers. So web server web. Oh my goodness gracious. Yes, we have all of that. So I'm actually going to copy and paste this section because it's really big. And then we're just I'm gonna go over it really quick because I need to catch up a little bit on time. So the next thing we're gonna do is we're gonna create a firewall. And what I basically am going to be doing is I'm going to be creating firewall rules for this. And then this is, we'll give this var.name. And then what we're going to do is we're going to say, apply these firewall, call this to all these droplet IDs and our inbound rules. So our inbound rules are, we're only going to allow inbound traffic from TCP, UDP, and ICMP from our VPC. So by using this firewall, I am effectively blocking out all traffic from the outside world directly to the web servers. The load balancer, since it will have a private IP address, will be able to speak directly to these. The Bastion server and the databases will be able to, because they're inside the VPC, but nobody outside of that will be able to talk to these. They will not be accessible via their public IP addresses, which, as you're going to see in a little bit, is going to create a problem when we want to SSH in, and that's why we need the Bastion server. However, I do use outbound rules to allow these to be to outbound to everything else. So UDP, TCP, and ICMP. So the web servers can also talk back to the Bastion, to the database, and to the load balancer. So basically, these 6 rules are let everything happen inside of the VPC. So all traffic is allowed inside the VPC. You could restrict this more if you wanted to, but you don't necessarily have to. And then I'm very selective with outbound. So I allow for outbound DNS, HTTP, HTTPS, and ping from here. Now, a very traditional architecture would be to not even allow this and to use what's called a NAT gateway, which essentially is a droplet that everything is routed through, and then it is given access, the droplets are given access only to that droplet, and that's how they get all their traffic. While that works, it's a little bit more expensive to have a NAT gateway, and just doing it like this allows for outbound traffic across DNS lookups, HTTP and HTTPS, and then ping. Ping in reality you don't even really need. No other outbound traffic will be allowed out. So it's kind of a trade-off of money versus not really security, but like just how much you want to follow really standard protocol. I personally think this is okay. Depending on the size of the project and operation you're trying to run, and it's going to save you a little bit of money by not needing a outbound NAT server, and it's also going to save you headaches whenever that NAT server goes down, because they do. All servers eventually at some point go down. That's just something we have to accept. And then the last thing I'm going to create real quick is a DigitalOcean record, which is basically our DNS record, and this is going to be a DNS record for our load balancer. So the domain is going to be data.digitalocean_domain.web.name. The type is going to be of an A record. The name is going to be var.subdomain. So this is going to be whatever we want to end up calling it. I think we end up calling it webinar. So this will be like webinar.egger.codes instead of www. The value we're going to say, we're going to point this to, value is we're going to point this this A record at our load balancer .web.ip. TTL of roughly 300 seconds. You should technically make these a little bit longer, but right now, since we're doing this live and stuff, we don't want to accidentally cause issues. And like if I do have to redo it, I don't want this DNS record to be stuck. Actually, we're gonna do it for 30 seconds right now just to kind of make my life a little bit easier. Okay, so that is all there is for the web server, and that's a lot. So we've created droplets with all of our correct, image, count, name, region. We created a certificate for our load balancer so it can do HTTPS. We've created a load balancer so we can balance our web traffic across our 3 droplets. We've created firewall rules to protect these droplets to let traffic flow freely within the VPC and then to block traffic. There's no inbound rule in here to allow any traffic outside of the VPC into these droplets. And then a couple of very specific outbound rules for allowing our droplets to be able to speak out. This will allow us to be able to, this allows us to be able to speak out and do stuff and like contact things that might have been wrong, what was with the droplets earlier. And then the DigitalOcean record web. So really quickly, I'm actually going to come back over here and I'm going to just destroy the resources that I have. I apparently have variables. Variables.tf seems to have a lot of crankiness in it. So let's look. Aha, did I not, do these, no, maybe these don't need to be in quotes. Maybe I'm just silly. Am I silly? No, it's working. What the heck? Nope, still same problem. Block type. Oh, do I have to put equal signs there? Is that what's going on? Yeah. Hooray for live coding, right? And then we'll see if some have quotes. Maybe it just accepts both. I wish it actually. Domain name. Did I not put that? Oh, destroy dash var file sfo3. I hate that the destroy needs a variable file. That really irks me. Data source has not been declared in the root module. Did I not save that file? That's no, it's right there. DigitalOcean domain.web, and then this is saying data.digitalocean.web.name. Interesting. Why is that not working? Is everything safe? Okay, we don't need main.tf anymore. We don't need the data sources anymore. We'll get to the outputs later if we even get to it. We don't need the network file anymore. That is so odd. Data.digitalocean.web.name. A data resource DigitalOcean web has not been declared in the root module. Did I give it the wrong name? Ah, DigitalOcean domain. Ha ha ha. Found it. That's on what line? It would help if I look at that. Web servers TF line 39. DigitalOcean domain. Load balancer web.ip range. Unsupported attribute. Web server line 153. What? Yeah, that don't make no sense. Why did I even write that? So it's IP. Okay, we're gonna go ahead and destroy those droplets and we're gonna be good. So, whew. Okay, good drink of water. How much time do we have? I have 15 minutes. Ooh, we might have to cut the database out of the architecture today because I should be able to finish the Bastion server in the next 15 minutes and then be able to take questions. We might be able to squeeze the database in. If not, all of this code is in GitHub and you can see all of it. This is my first time blasting through this live, so it is kind of fun, kind of nerve-wracking on my end, to be honest, because it's always fun to have everybody scrutinizing me whenever I'm doing stuff. It's like, don't mess up, Mason. Good. Those are destroying. I can just wait. I'm not that concerned about waiting on that. Next step. So we've created, back to architecture. We've created this awesome thing. So right now you can just, if you put your hand and cover up the Bastion in the database, that's what we've created. The only problem is that you have no way of accessing your web servers right now because you haven't given yourself any way in. If I try to SSH in to these servers, come on. Oh, I haven't even applied it. If I try to SSH into these servers, I will not be able to because we have effectively blocked off private network access. Well, how do we do that? We can use what's known as a Bastion host or a jump host. This allows us to kind of proxy our connection through using something called SSH agent, which allows you to add key values on your local machine to an agent, and then the agent gets forwarded through and then can unlock it. So what we'll do is we'll be able to jump SSH into the Bastion, and then from the Bastion SSH into the web servers using the key on our local machine without storing anything on the Bastion, which is useful because some people may, and I cannot delete the default VPC. That really irks me. It's fine. That's fine. I don't care. Everything else is fine, so we're good. I'm a provider. I mean, write that down as a bug, and I need to fix that because we just added that. Anyways, where did my brain go? It left me. Oh yeah, Bastions. We're gonna go ahead and add a Bastions file. If you think that I'm a little bit kooky, you may be right. Bastions.tf. We're gonna call it Bastion.tf. We're only gonna create one Bastion. This is actually a relatively easy one to do because it's very similar to our other one, and actually we are pretty much going to just copy and paste this resource. So we're going to put it in Bastions. We're going to change the name of this to Bastion. We're not going to do a count because I don't need more than one Bastion right now. Now, there is the thing is, well, what if the Bastion goes down, then I can't get in? Yes, that's true. You could always just use Terraform to taint the Bastion and then re-spin up the Bastion. Or you could create multiple Bastions and put them behind a load balancer, and then that would also work. But at the same time, that costs way more money. So it's kind of the redundancy versus money argument. And in this case, because I do call this minimal, like this is not, and we're gonna make it the same drop. Well, actually, we're gonna set this to something else. Since I do call this minimal, then it's gonna be minimal. In reality, if I was personally doing this for a larger scale company, I would have a load balance set of Bastions to make sure everybody could get in. And that's actually the next architecture that I'm working on. So once I release it to GitHub, you'll be able to see that one. But for now, it's meh. So we're going to go ahead and do that. And that's basically all it is. It's going to be the same image. It's going to be a Bastion. We're going to actually hard code the size to 1 CPU because jump hosts don't need a lot of resources, to be honest. We're going to go ahead and add a DigitalOcean record. I'm just going to start copy pasting from now so we can make it work. Same thing as a DNS record. We're going to basically get the web name. We're going to create an A record for it, and we're going to set the IPv4 address of the Bastion to it and set the TTL. And then the last thing we're going to do is we're going to add a firewall for the Bastion. We're basically going to say give this firewall this name, so name-only SSH Bastion. Which droplet do I want to apply this firewall to? Just the Bastion firewall. The inbound rules we're going to do are we're going to allow inbound and outbound TCP and outbound ICMP, so I can ping servers inside of the network and I can SSH them, but that's all I can do. This sort of lockdown is what kind of prevents your Bastion from sort of being compromised because the only port that things can jump across through will be through SSH. And really and truly, there's going to be SSH out there, so it's going to be a lot more difficult. And this is a Bastion server. It's a little itty bitty droplet that you use as an access droplet. Let me see what else. So it is 12:48. I want to leave a little time for questions and a little bit of time for demo. So that being said, I'm not going to get to the database. Again, where's it at? It's up here somewhere. do.co/tf-sample-arcs. This one's called 01-minimal-web-db-stack because I'm terrible at naming things. It has a full thing on how to create the database cluster. Actually, yeah, well, we're gonna skip that today because the database in and of itself sometimes can take up to 5 minutes in Terraform to stand up, and we would lose a lot of valuable demo time for that. So what I'm gonna do now is I'm gonna just go ahead and do it without it. We're gonna apply, and we have 10 to add, and that's a lot. So we're gonna just really quickly read it down once I find the top. So we're gonna create the certificate. We're gonna create a Bastion host. We're gonna create 1, 2, 3 web servers. We're going to create a default firewall for the Bastion, only allowing SSH in. We're going to create the firewall for the web that will give us all of our kind of like blocking everything off and making everything talk across the private network. Inbound traffic traffic inside of the VPC is allowed. Traffic into the VPC from external, not even mentioned, which means it's default. It's a default deny firewall. And then outbound traffic, we're going to allow a little bit of stuff out. Mostly across a couple of them. We're going to create a load balancer for our web services that is going to have the domain name created on top of it with the HTTPS certificate. We're going to create a DNS record for our Bastion so we can easily ask it. It's going to be bastion-webinar-sfo3.egger.codes. And then we're going to create a record for the web, and that's a lot, and we're going to go ahead and say yes. So it's going to start applying and creating. There are a lot of things. So, whew. So again, while we're waiting on this, the short code is do.co/tf-sample-arcs. Also, this Terraform sample DigitalOcean architectures is in the DigitalOcean GitHub repository or organization. So if you go to GitHub and you go to the do-community organization, and you will see all the projects associated with it, you will see Terraform sample DigitalOcean architectures. If you just type in Terraform, you'll find it pop up really quickly. But as you can see, like I said earlier, you spend, as an SRE, as someone who has done this, you spend a lot of time, you spend a lot of time waiting on Terraform. There were times that I would spend waiting 10, 15 minutes for large scale production things at my previous job. I don't know if I did an introduction earlier. I'm a past SRE. So now I call myself a reformed SRE who now talks about stuff. Okay, so we have 3 A records, which is what I was expecting. Kind of. Good enough. Let's see. HTTPS. Sweet. So if you go to https://webinar.egger.codes, you will see, looks like number 3 didn't provision properly with cloud in it. Oh, no, there it goes. It was just taking a little bit of time. So as I refresh, you can see it refreshing through, and web SFO3 and all that. It just takes a little bit of time. Cloud in it is in and of itself its own fun little ball of nightmares. When it works, it's amazing, and when it doesn't, you are been there, done that. Don't want to do it again. So now, if I get the public IP address of, say, one of my web servers, I will not be able to get through to it. It's not going to go through because we do not have it open. If I try to SSH to it, it will not work. So what we're going to do now, the SSH IP address is of the, we're just going to do it's SSH. We're going to say I'm SSHing as root. You can always change this later. Trust me, you want to. Just right now, I didn't get around to it. Webinar.sfo3.egger.codes. Yes. Oh, wait, no, my bad. You want to do -A when you're patching the agent. So when you pass the agent, now it's taking my SSH agent and letting me in there. So whenever I come over to the DigitalOcean console, I can click on my server and I can see that the private IP of webinar SFO 3-2 is 192.168.44.5. So now that I'm in my Bastion, I can SSH in as root at this, and I'm actually in there. So if I go to cd var www and HTML, and I open the index.html, and I do an h2, I am in the server, h2, and then we come back over to this. I am in the server, but I only got into number 2. And then if I wanted to change stuff, I could SSH into each individual one. This will allow you to do like Ansible kind of stuff, configuration management stuff, and all of that. So let me go back to my PowerPoints. Shift F5. Thank you for putting it on the wrong side because Microsoft just has to do that to me. Thank you for attending. This code can be deployed today using Terraform. All of this is in GitHub, ready to go. You can deploy this exact thing plus a database because I didn't get to it using Terraform today inside of this directory at this website. If you have other architectures and stuff that you want to see me do, I've already got a request for one on using some Kubernetes stuff, but like maybe you want to see what I don't even really know, like maybe like what a containerized application space would look like, or what like maybe if you want to do something for VPN, something for gaming, which I don't really know a lot about gaming, but I can try. If there's any architectures that you would like to see, fill out that request. It basically just links you to the issue tracker. Let me know if you find issues in this because it's broken. Let me know too. That would be really helpful. If you want to try all of this out and you don't already have an existing account, you can sign up for a new account using do.co/tryprodinfra and get $100 credit for 60 days. And that is all I have for today. So I am going to go ahead and wait for the magic voice that asks me questions.
Thank you so much, Mason. We have a bunch of questions and we'll try to get to as many of them as possible live. If we don't get to your question, we'll try to answer it via email afterwards. So someone says they didn't notice you actually shutting down the public IP addresses of the servers. Do you do that as a matter of course or just rely on the firewall to restrict access?
So that is a great question. Right now, I literally just rely on the firewall. There is a way to shut down the private IP address, but it requires this weird like config file. It's in our documentation on the VPC, and it was not as straightforward as one would think it should be. Like I spent a long time figuring out how to do it. In a perfect world, yes, I would shut down the perfect IP address because while I do trust the firewall, you know, the more layers of security you have, the better. For this minimal architecture, I did not. But if it's something that you would want to go in and do, or because you're going to need to configure these servers beyond the fact, you could totally use something like Ansible to turn it off. So it's definitely a good idea going forward. And you know, hopefully one day we may have that option available for you. I have no idea. Don't hold me to that, but it would be nice. But yes, you can turn them off yourself. But me personally, as of this architecture, I'm relying solely on the firewall.
Cool. What does the VPC really do if all the traffic is blocked or allowed through firewall rules?
So the VPC, the purpose of the VPC is we are blocking all inbound traffic to our web servers from the outside. So nobody can you can't DDoS like the AD server on that. You can't port scan us because none of that traffic is ever going to connect. Now you could do it to the load balancer, but at the end of the day, I believe that load balancers have some level of protection above that. By allowing no traffic out in, and actually the important part is not allowing traffic out, because we only allow port 53, DNS, HTTP, and HTTPS, and this is just so I can install the correct packages. In reality, once I'm done doing the Cloud Init, because Cloud Init reaches out to the Ubuntu servers to get the packages to install Nginx, I would actually shut that off, because if somehow, some way, something was injected or a piece of malware got on, or somebody created a virus. That virus is, or someone's trying to create a botnet out of you and mine Bitcoin and send it off. That's a very common issue that we see in cloud all the time. With the VPC blocking outbound traffic, it can never phone home. It can never make that connection back out to say, hey, I'm part of the botnet. It would never come up. It would never be able to get the connections and create that, because typically what happens in a security setting is you get a piece of connection, you get a piece of software on a server, and it creates an outbound established connection, because outbound established connections, typically sysadmins don't really monitor them as much as they should. We're always worried about someone breaking in. Well, what happens is somebody drops a little virus on your machine, and then it calls the outbound, and since it's an outbound connection, you have established connection, and our firewalls do allow established connection communication back and forth. I mean, that's typical, that's industry standard. So not allowing the outbound really, really helps, and it makes sure that you don't really get compromised. Or, I mean, it doesn't prevent you the compromise, but it's again, security happens in layers, and this extra layer prevents a lot of this kind of nasty stuff from happening, and it lets you rest a little bit easier at night knowing that no one's hammering on your servers, constantly port scanning you. Maybe you forgot to correctly, maybe you're talking over the public internet. Also, I know this is a long answer. This now allows all of your droplets to talk over private internal communications. Previously, if you created 2 droplets and you only had public internet, all of the communications between that traffic goes out of the DO data center and then back in via a public internet connection. Now, I don't know if it actually goes all the way out, but it was happening over public internet where anybody could see the traffic. The VPC now also allows all this communication to happen in a private network that you control, that other people aren't able to be inside of. And it's honestly, I've been waiting for this feature. I've been a customer of DO for like 5 years. I've been waiting for this feature forever. It's an amazing feature. I highly recommend, if you build stuff, you should be building them in a VPC just to protect your traffic. Sorry, that was a long answer.
Thanks so much, Mason. And sadly, we're out of time. And thank you, everyone, for all the wonderful questions. We're sorry we can't get to all of them live today, but we'd be happy to answer them via a doc after this tech talk. So look out for that email from us. Look out for that video, and let us know how we did today and what you'd like to learn more about next time. Any parting words for us, Mason, before we hop off?
I think I'm good. Feel free to, if I go back on my, let me just go back to that. If you follow me on Twitter, I will, at Mason Egger, and you tweet at me, I will also answer your questions there. I will answer all questions in the chat on the doc, but if you think of one later and you want to go ahead and reach out and ask, I will happily do this. This again, one thing, this is, a lot of this is all like my opinion on how I would build servers. You will definitely be able to find other people that think differently, but I did run, I was an SRE for a very large travel company for quite a while, and I learned a lot of really good tips and tricks for them. So this is just everything based on my personal experience, but as always with all of this, there's always varying opinions. So Phil, I hope you take what I say, but if you find a better opinion out there, hey, go with it. At the end of the day, do what works for you. And that's what we have to remember, is there's a lot of good advice, there's a lot of good blog posts, a lot of people out there that put a lot of stuff into the universe, but what works for you and makes your business work and makes your product work is what's most important in reality. So yes, thank you everyone for attending.
Thank you, Mason. Everyone, thank you for tuning in. Have a great week.
Bye-bye.